Here we want to solve for x being between 0 and 360 degrees. And if we're looking at sine of x equals 1/2, then to get rid of the sine, what we do is take the inverse sine of both sides. So the inverse sine and the sine, they cancel and just leave us with x. And on the right-hand side, the inverse sine of 1/2, making sure you're in degree mode, is going to be 30 degrees. But that's not the only spot on the unit circle where we'll get a sine that is 1/2. So think about this 30-degree angle. 30-degree angle is right here. And the thing about that 30-degree angle is that it gave us a sine, the y-coordinate here, that was positive 1/2. Now, which other quadrant would also give us a sine, a y-coordinate that's positive 1/2? And that's going to happen over in the second quadrant, because the y-coordinate here would be positive 1/2. So these two angles would have to be the same. They're two reference angles. So this 30-degree angle would have to be the same as that 30-degree angle. But the other x value that we're thinking of beyond this 30 degrees is going to be this angle, which is 150 degrees. And there's our two angles. So let's do this again, this time with cosine. Where's cosine? 1/2. Well, we can take the inverse cosine of both sides. So over here we'll take the inverse cosine of 1/2. These guys cancel, we got x. And the inverse cosine of 1/2 is that angle that gives us a cosine of 1/2, and that is going to be at 60 degrees. Right? You can type that in your calculator, make sure you're in degrees, all that. But now let's think about this again. 60 degrees is right here. And the important thing about this 60-degree angle is it gave us an x-coordinate that was positive 1/2. Now, which other quadrant gives us an x-coordinate that's positive 1/2? Well, that's going to be the fourth quadrant. So what is the 60-degree angle in the fourth quadrant? That's going to be 300 degrees. Let's do it a few more times. Taking the sine of x is 0.2. In order to solve this, x is going to equal the inverse sine of 0.2. And for this one, we are going to have to grab the calculator, making sure you're in degree mode. Hit the inverse sine of 0.2, and you get 11.536 degrees. Now we have to find the other angle. Well, think about this. Here's 11 degrees. That gave us a sine that was 0.2, positive 0.2. Which other quadrant has a positive sign? That would be this one, where we get a positive 0.2 for our sine. So what we're looking for is the second quadrant angle, whose reference angle is 11.2. So just take the 180 and subtract off that 11.536, and we'll get our other angle, which is 168.463. Let's do it again with cosine. So where's cosine of x is equal to negative 0.2. So x is going to be the inverse cosine of negative 0.2. And so we grab the calculator and find the inverse cosine of negative 0.2. And that gives us an angle measure of 101.536 degrees. Now we have to find the other angle. So think about 101 degrees. That's right over here. That gives us a cosine that is negative 0.2. Right, in the second quadrant. Which other quadrant has an angle measure, or an angle measure that will give us a cosine of negative 0.2, and that would be down here in the third quadrant. So looking at reference angles, since the angle that we're looking at is 101.536, that means its reference angle is 78.463, which means this angle right in here is 78.463. Similarly, this angle right inside of there would be 78.463. So the second angle that we're looking at, this was our first one, the 100 degrees. Our second angle is going to be the one that wraps around down to this third quadrant. And that's going to be 180 degrees plus that 78.463 degrees to give us our second angle of 258.4 463 degrees. One last time. We got sine of x is equal to 4.5. When we try and do this and we get x is equal to the inverse sine of 4.5, we go ahead and type that into our calculator, inverse sine of 4.5, and what we get is an error. Okay. And the reason for that is, going back to the original equation, I'm trying to find an angle measure that'll give us a sine of 4.5. Well, sine is never going to be bigger than 1. And so that's why how we should have known right away that this answer does not exist.